Hello everyone, welcome to NCERT Physics Simplified, and in this video I'll explain you chapter number 9 of NCERT Physics class 11. This is chapter number 9, mechanical properties of solid. Okay, so in this chapter we have to understand the properties of solid, elastic behavior of solid. These are the main point that we have to discuss. The stress and strain, we have to discuss Hooke's law, stress strain curve, very important curve, stress strain curve. Okay, and then we will see the application of elastic behavior of material. Okay, so it's a very small chapter. Okay, so let's just look at the introduction paragraph first. Okay, so in this, the main things, I'll explain you the main thing in this chapter. Okay, so first of all, the mention is of the elasticity. Okay, so what is elasticity? So when we apply force to a body, to an object, okay, so the force, the deforming force, like I compress this body on the this is a rod, suppose, and I apply very large force on both sides of this body, this rod. So what will happen? What does the force do? It will surely deform this body. So this is a deforming force acting on this body. Okay, so I'll just, for a second, I assume that it is, suppose it is a spring. Okay, it is a spring. Suppose I had applied force on a spring. So can you tell me what would have happened if I apply a deforming force on a spring? Yes, obviously you have guessed. So after I have removed the deforming force, it will return to its original position. Similarly, for the bodies, for the solid bodies, any solid body, okay, not all solid bodies, certain solid bodies, when we apply deforming force to them, after the deforming force are removed, so they come back to their original position after the deforming force are removed. Okay, and this property of a solid, by which they tend to regain their original size, this is called elasticity. Okay, so first topic is elasticity that we have to understand in this chapter. Okay, so I'll just read the important points of elasticity. The property of a body by virtue of which it tends to regain its original size and shape when the applied force is removed is known as elasticity, and the deformation caused is known as elastic deformation. Okay, so this property by which a body regains its original size and shape is called elasticity, and this deformation caused, okay, is called elastic deformation. Similarly, opposite to this, okay, certain bodies have, certain objects have a tendency not to regain their shape, like for example mud or putty. When you apply deforming force to a clay, when you apply deforming force to it, does it regain its original shape? No, it doesn't regain. So this property is called plasticity, by which they are permanently deformed. Okay, so these are two opposite terms, elasticity, plasticity. Okay, a steel, okay, has elasticity, rubber band is elasticity, while putty, mud, they have plasticity. They are got plastic bodies. Okay, now, so this will play this plasticity, and the plasticity will play an important role, as we will play an important role in engineering design. For designing building, we have to take care what is, we don't want the material used in the bridge to be deformed when deforming forces are acting. When traffic is moving over the bridge, we don't want to it get deformed. So we need, we'll explain a term, Young's modulus, later. We will use a material which has larger Young's modulus. Okay, that is, it will not deform easily. Okay, so, and then we'll see some of the thing, like why I-shaped pillars are used in railway tracks. Okay, so this will be some answer. Ropeways, how much load they can bear, what things we have to keep in mind while designing them. All this will be answered in this chapter. Okay, so then we'll see elastic behavior of solid. Okay, so now as I told you that when we compress, when you apply force on a solid, what will happen after the deforming force are removed? so they tend to regain their original size and shape. So what is the cause of this? Okay, it is the cause of this is mentioned in this paragraph. Let's understand. We know that in a solid, each atom or molecule is surrounded by neighboring atoms or molecule. These are bounded together by interatomic or intermolecular force and stay in a stable equilibrium position. Okay, now the atoms, there are, as we know, matter is made of atoms. Similarly, in solid, these are made of atom and they have a certain fixed position in solids. Okay, now this atom is surrounded by neighboring atom. It is bonded to a neighboring atom. Okay, so when I apply force to it, okay, when I apply force to it, what will happen? It will be displaced from its equilibrium position. Okay, and the intermolecular distance between them, these two atoms, will decrease. Hence the intermolecular forces will increase, and this is the reason for the deforming force. You can understand this. A spring and ball model is given. Okay, imagine the atom has the balls and they are connected by springs. Okay, so what we do, this is an equilibrium position. Now if we apply force to any part of suppose you apply force to this ball. When I apply force to this ball, what will happen? It will be deformed. Okay, now it will be deformed, and because this in the spring, restoring force will be developed. Okay, and it will try to, because the atoms are now closer to each other, and they will try to come back to their original position. Restoring force will be developed. Okay, because of the intermolecular repulsion, and they will come back to their original position, and so you will regain its shape. So the elastic behavior can be understood by this ball and spring model. Okay, then yeah, now we'll discuss a law that was given by Robert Hooke, that it says that the stress under the elastic limit, what is the elastic limit? We'll understand. The stress is directly proportional to strain, or the ratio of the stress to strain is a constant. What is the stress? Okay, well, let's first understand what is stress. Stress is basically force acting per unit area. Force acting per unit area. This is stress. Okay, and not just force, this is restoring force. So restoring force acting per unit area is stress. Okay, stress can be of different types. Okay, just let's first understand this stress in detail. I'll just skip this paragraph and I come back later. Okay, now see, so what is stress? As this is mentioned in this paragraph, the restoring force per unit area is stress. Okay, as I told you that when I displace this spring ball model or the elastic metal, okay, elastic solid body, it comes back to its original position. So definitely there is a restoring force that is developed inside it, and this restoring force per unit area, we have given it a name, stress. Okay, so now this is and make sure to remember that this is restoring force per unit area, not deforming force per unit area. Okay, in most of the time they are equal, but it is actually the restoring force per unit area. Okay, I'll give an analogy to this. It's not a very good analogy, but it will help you to understand why we are saying about deforming force, but that why stress is termed as or defined as in terms of the restoring force. Like there are so many things happening around us. Okay, will it cause stress to us? I'm not talking about this stress now, the other stress, the psychological stress, all the things that happens to us in our daily life. Does they cause stress to us? Only when we think about it. Okay, then it causes stress. Similarly, the deforming force is not causing the stress. Actually, this is the reaction to that restoring force that is developing, that is causing the stress. Okay, that stress is deforming force upon area, and you can figure out the unit. Okay, figure Newton, this is Newton and this is per meter square area unit, and we know this is equivalent to Pascal. So SI unit is stress is Newton per meter square or Pascal. Dimension you can easily figure it out. Okay, from the dimension of force in area, this is ml to the power minus 1 t to the power minus 2. Okay, now there are we can have divided classified stress into different categories. Like there are, first category is the longitudinal stress. What is longitudinal stress? Okay, now suppose there is a rod, okay, and we applied a force on both sides of this rod normal to its cross section area. Normal to this is the cross section area. You can understand, like if I cut this rod with a knife, that it will a cross section area. Okay, so I applied force, equal forces on its cross section area, and this force per unit area, and this you see, this is along the length, okay, normal to the area of cross section. This has a name, and this is called longitudinal stress. Okay, now longitudinal stress can be of two types. It can be like, in this case I was compressing the rod. So when I am compressing the rod, the restoring force developed per unit area is compressive strength. So longitudinal stress has two types, compressive stress and the other one is tensile stress. Now the tensile stress, we see tensile stress. Now what happens if I take this rod and I just stretch it? I apply force on both the side of it and stretch it. What will happen? It will make it longer. There will be restoring force develop, and they will make it, when the deforming force are removed, it will try to bring it back. So this, in this case, when the elongation is there, okay, this is called tensile stress. This is opposite to compressive stress. Compressive stress, we are compressing the body, the rod. In this case we are elongating the rod, but both falls in the category of longitudinal stress. Okay, so the formula will be same, that is for both the cases, this is increase in length. Okay, now we'll first let's look all the stress first, then we'll come to strain later. Okay, now the second type of stress is the tangential stress or the shearing stress. Okay, so is a figure given here, and you can easily understand with the help of this figure. Okay, so what is we are doing? We are applying force to this book. Okay, in this book we are applying force, but we are applying force tangentially. Okay, so how tangentially? Such that you can just do it by yourself. Place the book on the table and apply a force on this side, from this side of the table, keeping and by pressing the book downward. Okay, such that this part, the lower part or the back side of the paper book is attached to the table. It will not move, only the upper part will move. So you will see, like you can see from this cylinder also, the cylinder lower part is fixed to the base, only the upper part moves. So this force which is acting tangentially to the body is called the shearing stress or tangential stress, because it's shearing the body. Okay, tangential or shearing stress. Okay, restoring force, this is called shearing. On a third type, we'll see that this diagram is very informative. You see, this is case of longitudinal stress, this is tangential stress, both do cases, and the last one is the hydraulic stress. Even it is one termed as normal stress. Okay, but in the ncert it is given the hydraulic stress is given. Okay, so what will happen? What is hydraulic stress? If I take a ball, okay, and a metallic ball suppose, and put it in water. Okay, so when I put it in water and a liquid, and the liquid we will see in the next chapter what liquid does, how liquid exert pressure. So what it will do, it will exert force on the liquid exert force on the liquid from all the sides. From all the side, liquid is exerting pressure on this solid object or a ball. Okay, and hence because of this pressure from all the side and these forces, you will see why this is normal. This forces acting are normal to the surface. Okay, in liquid chapter, next chapter, mechanical property liquid, we will understand why it has to be normal to the surface. Okay, then this is normal to the surface. Okay, and the restoring force develop here, it will obviously, this deforming force will decrease the size of the body. It will change the size of the body or the volume. There will be change in volume of the body, but there will be, is there any change in the shape of the body? The answer is no. The shape will not be changed, only the size will be changed. The restoring force developed here, the restoring force per unit area developed here is called the hydraulic stress. Okay, so 3 types of stress we have discussed. Now we'll come to the strain part. You see, first case we have seen 3 types of stress. The first was the longitudinal stress. Okay, the length was increased or decreased on applying the compressive or tensile stress, and in that case what will happen, the force will increase or decrease the size of the rod, and that increase and decrease of the size of the rod, that is the change in the length, it will change the length. Suppose it was 100 centimeter rod, by applying the deforming force, what we do, we make it of, here was a decrease in maybe 5 centimeter, that is a little more, but just let's say 5 centimeter. So this change was 5 centimeter, the original dimension was 100. This is called longitudinal strain, original change in length upon original length. Then the second one was the shearing strain, shearing stress. Okay, so in this case, you see, the lower part was fixed, the upper part was moved. So let's assume that is the length of this cylinder was L. Okay, and the length of this cylinder L, or the height of the cylinder was L, and because of this tangential force, the upper base shifted or moved with a distance delta x. Okay, so how much is this the shearing strain here? Shearing strain on this case is the distance by which this two, the relative distance moment or the relative displacement between the two planes, how much these two planes have moved related to each other, so delta x they have moved. Okay, upon to the distance between these two parallel planes. Okay, this is, so that is delta, that is L. So delta x upon L, this is what, this is shearing strain. Okay, and you know, from this is forming a right angle triangle. If you see here, this is forming a right angle triangle here. This is L and this is delta x. Or for small angle, because the angle is very very small, the tan theta will be what? Tan theta will be perpendicular, that is del x upon pi base, del s upon L. For small angle, theta and theta is equivalent to theta, and this is equal to delta x upon L. So this is shearing strain. Okay, next type of strain, and this is hydraulic, for the case of hydraulic stress, that will be volume will be changed in this case. The change in volume per unit volume, the change in volume per unit volume, this is called volumetric strain, which is caused by the hydraulic stress. So volumetric, it is given here, volumetric stress strain delta V upon V. And you know, one important point, strain has, because it is a ratio to the change in dimension upon original dimension, so it has no unit. Okay, no unit. Okay, now, and okay, no unit and no dimensional formula because it is a ratio. Now we are ready to discuss very important law, that is Hooke's law. So I told you, okay, for small deformation, that will be under the elastic limit, before the elastic limit even. Okay, what is the elastic limit, we'll discuss in the next paragraph. Okay, for small deformation, the stress and strain are proportional to each other. Okay, so suppose I'll just give you this is an experiment actually. I'll just give you idea of the experiment that will help you to understand this. Okay, now see what I did, what I put. Yeah. Okay, suppose I take a rod. Okay, so this is of, suppose how much, 100 centimeter rod. Okay, and then I applied force to it. Okay, a better way is to take a rod, wire, okay, or the spring, and put weight to it. We'll put weight to it. Okay, and by we'll just keep increasing this weight. We'll put a rod here, or we for a rope or rod. Okay, and we'll just attach a weight to it, and we'll just keep on increasing a weight to it. Okay, there's an experiment actually given to verify this. Okay, let me see that experiment is it was given in the okay, right now I cannot find the experiment. Maybe in the next paragraph it is given. Yeah, this experiment, you see. So what we'll do, this is a wire, experimental wire, this is reference wire. So we'll just keep on putting the weight here. Okay, and when we'll keep putting the weight here, we'll observe that we'll observe the reading, how much the length is increased of the wire. Okay, so we come to know that as the value of weight we are increasing, the more weight we are increasing, the length is increasing, and they are increasing, we'll find a relation. The more the weight we put, the more length is increasing. It is directly proportional up to certain for small deformation. This is Hooke's law. Stress and strain are proportional to each other. We'll discuss this experiment later. Okay, so this is stress is proportional to strain. More will be the stress, more with the strain, and the ratio will be a constant. So when we draw stress to strain curve, so it will be a straight line. Okay, stress is directly proportional to strain. So will it be proportional to that at all points? No, it will not be proportional to at point for small deformation. This is the condition. Stress is directly proportional to strain. Okay, and we have now, when we remove this proportionality, we'll encounter a new constant, and this constant of proportionality has a name. It is called modulus of elasticity. Okay, modulus of elasticity.